Hey guys, welcome back. We got a Nernst equation example. All right, so we have a cell potential for an electrochemical cell depends on the pH of the solution in the anode half cell. All right, so you know the pH is in the anode, so that means H is oxidized. All right, and we got platinum, hydrogen gas, hydrogen ion, and there's our question right there. All right, what is the pH of the solution at the measured cell potential? All right, measured cell potential is 355 millivolts. And so we have H2 gas at 1 atmosphere. We have copper here at 1 molar. All right, what is this platinum? Well, platinum would be an inert electrode. This is our anode, which means oxidation. And our cathode, which means reduction. All right, so who is being reduced? Copper 2 plus, it's going to copper, right? So Cu 2 plus in solution plus 2 electrons going to Cu metal. And that cell potential is 0.34 volts. So you'd have to use your cell potential chart or the book to look that up. The oxidation would be what? Well, it would be H2 gas, right, going to 2H plus in solution plus 2 electrons, and that standard reduction potential is 0 volts. And so if we add these up, we would have Cu2 plus in solution plus H2 gas. All right, and if we notice we got 2 electrons and 2 electrons, that's good. We would get copper metal plus 2H plus in solution. All right, and our standard potential to be 0.34 volts. Our measured potential, E, is 0.355 volts, if we keep in volts. All right. Whew. Well, what's Q? Let's do Q. Our reaction quotient would be equal to what? The concentration of H plus squared all over what? Well, it looks like concentration of copper 2 and the pressure of H2 gas. Oh boy. Fun stuff. Nernst equation. E equals E standard, right? Minus RT all over NF, natural log of Q. And again, what are we looking for here? So if we look, I'm looking for that, H plus. All right. Woo. Woo, 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 woo. All right, do we know what N is? Well, N, we got N. Do we have copper 2? Copper 2 I have, so we can highlight that. We have the pressure of H2, we have that. We know what F, we know what T is, right? We're going to assume temperature. It's not, all right, that's what we have to do. Obviously, if you change the temperature, you would just change what T is. We got E standard. I think we can solve. All right, let's plug in some numbers here. So E equals E standard minus RT NF natural log, concentration of H plus squared all over concentration of copper 2, pressure H2, and that's all in the natural log. All right, so E we got 0.355 volts. Equals 0.34 volts minus 8.3145 joules per mole Kelvin. 298 Kelvin all over. We have 2 moles of electrons, and we're going to have 96,485 coulombs per mole of electron. And then we're going to have natural log. We're looking for the concentration at H+. We got copper at, I used orange, 1 molar. And we have pressure as 1 atm. Well, how about that? That makes it nice. All right, let's do some moving here. So first thing we have to do is subtract minus 0.34 volts, minus 0.34 volts. All right, so we get 0.15, I'm sorry, I can almost do math, 0.015 volts equals negative 8.3145 joules per mole Kelvin. 298 K. 2 moles of electrons, 96,485 coulombs per mole. And then we're going to have natural log of the concentration at H plus squared, because the other things cancel as 1. All right, so now we are going to take everything on the bottom and multiply, and everything on top we're going to divide. All right. So if we do that, let's just get going here. 0.015 times 2 times 96,485 divide negative 8.3145 divide 298. I get negative 1.6823080565, and sig figs, we really only have 2. Unless you could argue 3, you could argue the 3. No, we have 2. We only have 2. Maybe even 1 with H2 won't be only 1 atmosphere, but we'll say 3 for our argument. So 1.17 negative. Negative 1.17 equals the natural log of H plus squared. Well, that means we have to do E to both sides, right? So now, second log negative 1.17, I get 0.310. So 0.310 equals the concentration at H plus squared. So I take the square root of 0.31. I get 0.557. Well, we know the pH is negative log of H plus. So the pH is negative log of 0.557. And so I'm getting, hopefully you get the same thing, negative log of 0.557, 0.25. Hopefully that's what you guys get too. If you have any questions on this, reach out. Otherwise, we'll see you in the next one. Take care.